Am I audible? Can you see my screen? Teja, Sai Krishna, and who is from Medistech? All right. In case if you have any questions, please unmute yourself and you can ask questions. So not wait till the end of the session. You can interrupt me at any point of time. All right. So before we get into generative AI and the content that we are going to cover in this course, we will understand what is an AI, right? Artificial intelligence, right? So let me take an example. Uh, let's take a robot. Where we have a robot here. Let's consider a robot. The brain is basically, we call it as machine learning or deep learning. So it's a product, out of machine learning or deep learning. Machine learning is basically a more traditional approach, as deep learning is a modern approach. It is not just modern, it can solve even more complex problems than what machine learning algorithms can do. So when I say machine learning, what I mean is machine learning algorithms. When I say deep learning, what I mean is deep learning neural networks. Okay. The remaining system, the whole ecosystem. So the brain will just give you the instructions, right? So it can't act on its own. Whereas the whole ecosystem need to build, to act according to the instruction given by the brain. So the whole ecosystem we call it as AI, artificial intelligence. Let me take another example. Tesla car. Everyone might have seen Tesla car at least once in our lifetime, right? So Tesla car is semi-autonomous car. So it has a bunch of sensors. So if you look at car radar, so you can understand much better. The older one, you can clearly see you can see that there are some sensors on top of it, right? In fact, it's much more robust than the typical Tesla car. Here you can see a lot of sensors, not just one. So basically, the LiDAR company they will provide these sensors, set of sensors. Even Tesla used to use this LiDAR sensors, and they have their own sensors. They build their own sensors. So basically, this LiDAR sensors or typically any semi-autonomous car, they will have their own sensors. They take they take input from the environment, right? It can be traffic signal, it can be road, or it can be vehicles nearby. It can be trees, near to the, road. It can be any object. It can be a flying object also, right? So it takes input from these sensors and it feeds to sensor data. It feeds to this machine learning or deep learning models. Model is basically, act as a brain, as I said before. It gives instruction. And based on this instruction, whatever the instruction that this machine learning or deep learning model provides, the whole ecosystem need to act accordingly. Let's take that the car the instruction has been given to stop or move right or left or take U-turn. So according to the instruction, the car need to act right. So car need to move. The car need to stop or car need to move forward or move backward, right or left or U-turn, whatever. So the whole ecosystem need to build according to it. The whole ecosystem we call it as AI. So basically, this is an AI product. So even a more simple example, let me take a website which has a chatbot in it. Right? This is an AI product we can call it as. Typically, we build models to embed it in web applications, or mobile applications, or desktop apps, right? So we don't involve, predominantly, we don't involve in building, semi-autonomous cars or robots. We mostly build models to embed it in chatbots or some way or the other in web applications. So as I said before, the machine learning or deep learning acts like a brain, and the whole ecosystem we call it as AI. Generative AI is basically is a subset of AI. There are a lot of domains in AI. One of it is generative AI. And in fact, the whole idea of generative AI is to generate the content. So what kind of content it can be? It can be text, code. Code is also going to, code I mean to say is Python or any programming language code. Text or code, or it can be audio, or it can be an image or video. In fact, video, we should look at it as an image itself because video is just nothing, nothing but a stream of images, right? So generative AI is basically a subset of AI that solely focus on generating the content. It can be text or code, or audio or it can be even image or video. For example, let's take what is generative AI. If I ask a question, says it has responded back again with some content. It has generated content. So we call it as, it's one of the examples for generative AI, right? Another one is, let's take that I have given content. It has summarized it into some 50 or some 100 odd words. So we call it a summarizing text. So this is again another example for generative AI. Let's take that, I asked to generate Flask API for machine learning model. It has generated the code. It's basically a Python code, backend API, right? So it's one of the examples, another example for generative AI. It can be, it can even generate image or video or even audio. So we don't, right now, we start getting better models in audio, whereas images and videos, still we are looking for, a better models. It's not that easy to get a better, a production grade model for images or videos because it costs billions of dollars. So there are two platforms we quite frequently use, Hugging Face, wherein you get free open source models. Another platform is Ollama, right? You get a lot of free open source models here. Of course, there are ways, you can deploy it in your own VMs. There are other ways like Bedrock that AWS provides, or Vertex AI, Google GCP, I mean, it's a Google Cloud Platform provides to you. A platform wherein you can take a model as an API. And even in Azure, we have Foundry, wherein you can access model as an API. So in order to, build your own VMs, you can access the model as an API. I have given a few screenshots here so that you can understand it better, right? You can see the Hugging Face, Olama. There are free, open source, free ChatGPT kind of tools wherein you can install in your own machine and you can, let me show you an example, MSTY. This is a free open source GUI app wherein you can install in your own machine. It's a desktop app. You can, pull up your own model, but the only constraint here is you have to have GPU in your machine. For example, let's take what is generative AI. That's a simple question. So I will switch to 2.5, which is much faster than Q3 because Q3 has the reasoning embedded in it. So let's take, where is 2.5? Yeah, here it is. What is generative AI? So it's going to typically load it into GPU. You can start responding. It's much faster. It has taken around 11.3 GB, right? So even if you don't have GPU, you can still try it in CPU, but you have to try a uh, less size model. I mean to say, let me show you an example here. In Olama, let's consider I tried for Pen 2.5, right? Let's take Pen 2.5 here. So I tried 14 billion parameter model. We can even try 0.5 billion parameter, which is much less in size, much less in number of parameters, less efficient compared to 14 billion parameter, but still you can try it in C++. So someone unmuted themselves. Like if you have any questions, let me know. Please mute yourself, Madhusudan. Please mute yourself unless you have questions. Madhusudan,
Hi.
please mute yourself. Yeah, please mute
Yeah.
yourself unless you have questions.
Sure. Yeah.
Thanks. So you not to bother about having GPU all the time. Of course, in production you have to have GPU. So 0.5 GB may not give, I know, I mean to say, effective answer compared to the models that we have for 14B, 32B, or even 32B. So 72B is obviously going to be the best. The answers that we expect from 72 billion parameters much more efficient than any other model that it provides. And it has tool support also. So we can connect to external tools. Okay. Those who don't know what is tool, let's take that the model is basically will have some cutoff date. Let's take that, you're in ChatGPT or somewhere else. When you ask a question, it tells you that I know it has information up to September 20th, 2024 only. So it doesn't have any information thereafter. So we have alternative tools. So we have external tools like Search API or Tavily, where it can connect to search engines like Google or anything else, like DuckDuckGo. It takes data from search engine and gives you up-to-date information. So that is when the tools will be helpful, right? Okay, so before we get into this, let's understand what sort of frameworks or libraries that we are going to cover in this course. So we'll start with Python. So you don't require to know Python, but if you know any other programming language like C, C++, Java, or any other programming language you can take, if you know it, it will be much better. Otherwise, you need to put a lot of effort. And Python, it's not a prerequisite to take up this course. We will start from basics, right? So NumPy and Pandas basically for data analysis. When you get data, you have to analyze it before you start cleaning or pre-processing or start building models. So NumPy and Pandas is very important for data analysis. The whole idea is to understand the data, clean the data, and pre-process the data. So that is when these two libraries are going to be helpful. And Matplotlib and Seaborn for visualization, for plots, for charts, right? So if you have millions of rows, obviously you at one glance you can't understand it. So visualization is going to play a major role in understanding the data. So Matplotlib and Seaborn for visualization. Of course, we have alternatives like Power BI and Tableau. Those are more, proprietary tools, to buy it, right? Whereas Matplotlib and Seaborn are open source libraries wherein you can install in your own IDE like Visual Code or Jupyter Notebook and start working on it. You can import it and start working on it. Mathematics and statistics, again, it's not a prerequisite to take up this course. We will discuss in detail whatever that is required for AI, generative AI. We will discuss those concepts. Let me give an example like how it's going to look like. Uh, so for example, statistics. So we will start how many branches of statistics, right? And what is the distribution? What is the difference between standard deviation and variance? And why we need standard deviation? What is just score? How it's going to play a role in machine learning or deep learning? Correlation or covariance. What is the model? So when we always speak, we always use this term model quite frequent, right? So what is a model? So we'll discuss that in detail here. And advanced statistics like central tendency, correlation, covariance, measures of dispersion, sampling techniques, statistic libraries that we use it for to get statistical information. Hypothesis testing, some mathematics like what is derivative, what is gradient descent, and what are partial derivatives, and how it's going to be helpful in our in machine learning or deep learning journey. What is AURC? So we'll discuss those concepts in detail. So it's again, mathematics and statistics is not a prerequisite to take up this course. We will discuss that in detail. When it comes to frameworks for deep learning, we will have detailed discussion about PyTorch and TensorFlow. We used to use PyTensorFlow a lot. Now we are, start using more PyTorch. For generative AI, again, we use PyTorch. Let me show you an example, like a project wherein we use this PyTorch projects. The whole course being drafted keeping a beginner in mind. So we prepared templates and provide you in detail, like so that's something that you can utilize it in your production. If you look at the scripts, these are fine-tuned scripts. These are all like, all in PyTorch, typical core Python and PyTorch. There's all PyTorch. The whole fine-tuning is being built using PyTorch, right? And Git and GitHub, of course, for version control, LangChain, LangGraph, LangSmith. So we use these LangChain family frameworks for generative AI. So in order to build generative applications, we have to know LangChain, LangGraph, and LangSmith. Okay. And vector database, FIAS, Chroma. In fact, there are many other. We can even use NoSQL databases for document to store documents, JSONs, to store vectors, and Docker for microservices. If you look at this one, we built APIs like this for both, single and batch inputs. We Dockerize this and we deploy it. So the whole set of commands will provide you. So you not to bother in mugging up these commands. And in order to test that API, we have a file altogether. So the whole end-to-end lifecycle will be provided to you. And as I told you that there are two ways to deploy your model. One, you can build your own VMs like Kubernetes service or EKS service, right? And then you can deploy your own models, or else you can use Azure AI Foundry or Bedrock or Vertex AI to utilize the models as an API and embed in your apps. And DynamoDB or Cosmos DB will store vectors. So if you let me give you a brief idea like what is a vector. So text or image or code or whatever, basically machine learning or deep learning models can't really understand it. So we need to convert that into numbers. So whether you take text or code or audio or image or video, basically the neural networks cannot understand it. So we need to convert all this into numbers, especially text or code. So we convert this into numbers, not any other number. So we create a vectors. We get a very large size vector. So we store it in vector DB or typically NoSQL DBs. That is when this DynamoDB or Cosmos DB come into play, right? ECR or ACR. So basically we store these Docker images. We build Docker files, right? And then Docker image on top of it. So with this command, we build an image, Docker image. So after building the Docker image, we need to securely save that Docker image, which is very essential for a Kubernetes cluster. So we store it in ECR in the case of AWS and EACR in the case of Azure. So we're going to cover all the major cloud providers like Azure, AWS, and Google Cloud Platform. Okay. And platforms as tools of platforms, as I told you, Hugging Face and Olama, wherein we take the models, open source models, we can embed in our own tools like LM Studio or MSTY that we have seen a demo on MSTY, right? This one of the tools. In fact, we will have more elaborate set of tools tested in your own mission. MSTY is predominantly for Olama models, and LM Studio is predominantly for Hugging Face models. So based on the use case, we need to pick one of it. GPT for all is another one, popular one. And there's another one, bold.ai for web applications. So basically, bold.ai will help us to build the end-to-end web application thing. So just with a prompt, it will give the complete set of files. It is going to create appropriate files and it's going to generate the code. So this bold.ai, even though we can build web applications using these sort of tools, but bold.ai is specifically for that particular purpose, right? So we are going to have a demonstration on this tool too. And the Aider is basically terminal based. Some case you're not going to get a graphical user interface. It's going to be complete terminal based. In that case, Aider is going to be very helpful. Or you can use, if you have Visual Studio, you can use Continue Extra, Continue or Klein. There are many other tools, but Continue is more, free, and you can, pull up your own models, Koalama models, and plug in here and play with it. You can fix bugs, you can generate code, you can generate documentation, you can generate QA testing cases. You can do a lot of things using Continue extension. When it comes to generative AI projects, we are going to have at least 10 to 15 projects by the end of the course. The whole course duration is going to be around 3.5 months, right? 3 to 4 months, I can say. And the duration is going to be 1 to 1.5 hours, Monday to Friday. Same time, 6 a.m. IST. So let me know if you have any questions. I have given few screenshots of various projects that we are going to have in this course. This is Azure Foundry. So basically, it's around 3 to 4 months and 1 hour per day, Monday to Friday. We are not going to have any sessions on weekends, but at the end of the course, we will have at least 3 to 4 sessions on weekends. Sometimes 1.5 hours is not going to be enough. So we need at least 3 to 4 hours. In such case, we will plan a session on weekend. We'll inform you prior, so you're not to bother about it. And it is not going to be more than 3 to 4 sessions for the entire course. So please unmute yourself, and if you have any questions, let me know. The complete content, you can go through it. So this is the complete content in PDF. But if you just search for VLR training, if you need the content, click on vlrtraining.com, not vlrtraining.in. So don't click on this. Click on vlrtraining.com. And here you have generative AI section. Click on that. And here you have course content, detailed content. This includes a more modern approach by modern approaches like Agentic AI, MCP, and A2A also, right? We will have vision projects or even audio projects, but we focus more on LLM models that are text models, text or code. Even we have better models in audio also. So we'll have projects on audio too. But the vision more projects are not going to be production grade because we don't have any open source models that are production grade. So we can't really use it in production. So we'll have projects, but not as much as we focus on LLMs. And in order to contact, I think you already have WhatsApp number. So here you have a number here. So this is again a WhatsApp number. You can contact them for any other questions. Yeah, please let me know if you have any questions. Teja and person from Medistack Institute. I think you're from Institute. Omkar, Kamal, and Madhusudan.
Yeah, Dhamodhar, one question they have. How many class it will take for the completion of the Python in general? What's your planning around?
Python, it is going to be around 4 to 5 sessions. Python itself, for Python. So let me give you how it's going to look like. So we'll discuss these concepts in details, right from operators, and to object-oriented programming concepts, exception handling. That includes exception handling. Yeah. So and just by learning Python it doesn't end, and it's not enough. In fact, we need to learn a lot of other frameworks like PyTorch or LangChain for generate more production grade applications. Right. Yeah. Any other questions? Yes, Omkar.
Yeah, fine. Dhamodhar.
All right, Kamal.
Yeah, so after this course, what is the expectation? Like, what kind of roles we can apply for, or
Hmm.
how is the job market, and where
Right
we
now,
will be
yeah,
suitable?
in AI domain right now, more than 90%, is on generative AI, because generative AI can generate any sort of content. It's almost like any sort of content. It helps us to automate things with just prompts, simple prompts, right? So, and with along with the MCP, model context protocol and A2A, it is becoming even more powerful. Everything is becoming from, let me explain with an example. The expectation is that by the end of this course, you'll get 2 years of real-time experience. Okay. Earlier, it used to be like this. Okay. So the hardware wherein it can understand only zeros and ones. Kernel and shell will help us in giving a more right to. So for example, let's take ls, right? It will give us the list of files that I have it in the current directory. So basically, I need to know these commands along with bash scripting, C, C++, C. If you learn C language, especially in Linux terminal, you can add bash scripting. That makes even more powerful. But again, this requires a lot of technical knowledge, right? In order to address the non-technical users, we come up with applications. We're in google.com. So wherein you not to know any technical stuff. Of course, a lot of technical stuff go through under the hood. But thing is that the web applications, it can be web apps, it can be mobile apps, it can be desktop apps. The intention is to address the non-technical person, layman, the end user. But building the application itself requires a lot of technical knowledge. Again, Java stack, it can be MERN stack or mean stack, right? We need, at least 3 to 4 years of experience you require in each stack, to build end-to-end production grade apps. That is how things were. Now things are moving towards LLM models. I mean to say, the LLM, generative AI is going to replace this intelligence or knowledge. So you don't really require 3 to 4 years of experience to build the applications. Just by learning the basics, 3 to 6 months of learning basics of any stack you chose, right? That is good enough. And along with generative AI, we can build production grade applications. For example, let's take, I need, uh, please give me Django API that serves a deep learning model, which is specifically fine-tuned for generative AI, LLM, to generate text. Let's see that what it does. So it is saying that how to start the project, how to initiate the project, and then what are all the dependencies that it has. And it is giving the project structure, the complete and the directory structure and files that it has to have. And it is giving me the code for each of these files that in this current diagram, right? For this, we need at least 3 to 4 years of experience, right? Now, these generative AI tools, right? So, are replacing this intelligence or knowledge. Your job is to learn the basics of that stack and then generate the code or generate the knowledge, whatever the knowledge that this generative AI models generates, utilize it and start building projects. So by the end of this course, you will get 2 years of real-time experience. And No, the roles that you can apply for is generative AI engineer or AI engineer. So when you need to read the job description, predominantly it is on generative AI, but sometimes it can be, focus on data engineering also using Spark kind of. They don't use the term data science or data engineering, but based on job description, you need to understand what role that you have to apply for. But for this course is specifically on generative AI. And this course being drafted in a way that you don't require any prerequisites to take up this course. The only thing you need is basic programming knowledge of any programming language you choose. Did I answer your question?
Yeah. Yes.
Damodar, I have one question.
Yeah.
By the end of this course, can we expect that, let's assume we have some application and we want to integrate AI into the application for the feature building,
Okay.
just to automate the process, this
Okay.
manual process. Okay. So can we, there could be two possible, no? Write your own LLM or use the existing LLM and add, train your own data to that LLM and customize the LLM to your application. So
Okay.
can we expect that, okay, at least use the existing LLM, customize it, and or use that as your for application feature development?
Okay. So as you ask this question, so one, you can utilize the open source, freely available model, right? That is one way. Can you embed in that application? Of course, you can embed in the application. We will see products on that. There's another way, that is fine tuning. Fine tune is basically for on your own customized data. For example, let's take finance data or HR data that is specific to your own organization, right, own department. In such case, we need to fine tune it. That is one of the ways to do it. The other one is using RAG. So RAG architecture, retrieval augmented generation. So you don't require to fine tune it. Of course, there's nothing wrong in fine tuning data. But what if the data is quite, changes quite frequently and it's more dynamic? Fine tuning is like we use it when it changes every once in a month or once in 3 months or 6 months. What if it changes even more dynamically? Then we use RAG. What if you don't have vector database? Then you have something called CAG. What if you have external tools or APIs to connect to? Then we use MCP. What if you have multiple agents and wherein you want to connect, you want to build communication between agent to agent, A to A, proposed by Google. There are multiple ways to do it. It's not one shot solution for all.
My question is around, can we expect this type of work? No, can we learn these kind of things after the
Yeah,
course,
yes.
by the end of
So
the course?
by the end of the course, you will have, you'll complete 10 to 15 parts on generative AI. In each of these categories, you will have at least 1 to 2 projects. CAG will have one project. RAG will have 1 to 2 projects. With vector database, in-memory data, database, and sometimes we need cache-based, generation. So you don't really require RAG. Something that you don't require, you don't, in order to store permanent history, then in that case, you can go for CAG, which is much faster than RAG. At least you will have 1 to 2 projects on each of these categories.
Yeah.
A fine tune, if you look at this one, I showed you a script, we have around 5 to 6 projects. This one, for example, it's a text summarization or sentence similarity, a question and answer, or film mass, or text generation, text classification. What about zero shot classification? So if you take a model, just give you the labels and it's going to work with zero shot classification. So you're not going to fine tune or you're not going to apply RAG or CAG as such. You can simply, let me show you. You can simply provide, these labels and it's going to act accordingly. So we call it as zero shot classification. There are other ways to do it. One shot classification, a few shot classifications. There are multiple ways to do it. Based on the requirement, you need to apply. Right?
Yeah, thanks, Tom.
So any other questions? Teja, Medistech, I think one person joined from Medistech Institute. Any questions? Please don't hesitate to ask questions. So this is the right time to ask questions. If you have any questions related to AI, uh, you can ask. But definitely by the end of the course, you will get 2 years of real-time experience. The reason why I said is we will prepare all in the form of templates. Basically, you don't get these sort of scripts in anywhere else, GitHub or somewhere else, YouTube also. So we build these scripts specifically for beginners, whoever takes our course. And even machine learning, let me show you how it's going to look like. So we all prepare in the form of template. So this basically you can focus only on this block. And the remaining template is like, key for all. Of course, you need to know the code. That's very important. But the whole thing, basically, we don't just teach you basics. We teach you the production grade templates. We'll provide you these templates so that you can use it in production. This is for regression only. And we have other templates like for classification. There are even more subcategories compared to regression. So in classification, we have binary classification, multi-class, multi-label. And we teach you in depth. So when I say we teach you in depth, so you can see this is a template for classification. For example, what is a model? How does it work? So I think we have shown you, right? Some point zero 0.5 billion parameters, 1.5 billion parameters. How these parameters are really being trained? So we have something called gradient descent, wherein we will explain you how the model works, how the values for these parameters are going to be found out. Again, you're not going to get an online. So you'll take initial start with 0. And we'll take a very small model. So we have only 2 parameters. And this whole process will help you to understand how it works under the hood. So let's take machine learning algorithm. It is not a magic, right? Basically, when we provide data to algorithm, it tells us what is the internal pattern in the data in the form of model. And it will completely hide the process under the whatever happens under the hood. This is one of the ways to understand what happens under the hood. We initially start with 0, and then we fit into the formula, and then we find out error and we recalibrate the coefficients, and then again it started keep improving. So 0.16, 0.18. Again, you can see that it started improving more and more. By the end of all the loops, you will get a better you get the precise value for these parameters. The whole thing you need to I will explain you in detail, at least 2 to 3 epochs, and your job is to practice it. And we'll provide you the interview questions also. And we'll provide you through Google Classroom. Let me show you how it's going to be. So we have, we'll provide you all the scripts through Google Classroom. This only on generative AI. Right, this whole content. And we have deep learning or mathematics, visualization, pandas, etc. All the scripts will provide to you. So whatever the concept that we discuss, it is going to be in depth. And we'll provide you all the scripts. So you know to prepare notes. 99.99% case, you know to prepare your own notes. You can focus on practicing things. Right? So any questions? Teja? Yeah,
One
go ahead.
question I have,
Yeah, Omkar.
Dhamodhar. I am from the testing background.
Okay.
So some companies are asking, no, especially for testing the AI models.
Okay.
So maybe I think will this help to apply for those kind of jobs? For example, if I see the JD, 80%
Okay.
generally generally I know, at least I have exposure experience on that. But there are few cases that they are asking some AI companies that are using AI, for the feature buildings. So
Okay.
testing those models, they're asking for from QA perspective. So will
Okay.
this score help to test that? Anyhow, that test case creation, there is a part of the testing, but at least this course will help in that part.
There are two things in when you want to test the model. One, testing the API that the model has been embedded to. The other thing is testing the model itself. Let's take that you want to check hallucination, right? Whether
Yeah,
the particular model has
model, model,
hallucination or not.
model for different
Yeah,
data sets, how the model is working.
yeah. It's not about different data sets. Basically, there are two
Mhm.
ways. One, testing the API that the API, no, just consider that the API has the model in it. So if you want to test it, test the models, this is one of the ways to do it. But if you want to test the model itself, like how well it works, right? Whether it has any bugs in it, whether it has any hallucination in it. So we're going to have detailed discussion on LLMs. Let me show you that one. System is getting stuck. Yeah. So here we have LLM internals. Yeah, here. Wherein will help you to understand the various use cases, where it may go wrong. For example, like test a hallucination, right? How do we test hallucination? How do we solve that? Second. I have given somewhere else. Let me. Here it is. You can see it. How do we test and find out whether a model has hallucination or not? How well it works, and how many types of models we have: base, SFT, and instruct-based models. In based on the type of model we need to test it. So we can't expect an answer for all. We can't expect the same kind of answer that we expect from instruct model from to the top base model. So how do we test those models? Those sort of cases will be covered in this course. As I told you, there are two types of testing. One, testing the API itself, wherein it has the model in it. The other thing is testing the model to find out how efficient it is, or whether it has any bugs or not, or whether it has any hallucination on it. There is another way to test it. So we have detailed discussion on that too.
Okay.
This is one of the examples. Like basically, there is such person like Oswald Polanyi. But some case it may give a wrong. It may give an answer as if it knows the answer. It creates an answer. So how to avoid such situations. So we need to train the data accordingly. Okay. So we need to train how to say no. Those cases will be covered in this course, and we'll have a detailed script for this one. Elements. Yeah. Any other questions? So the script is going to be like this. Here we have this one. Pre-train, tokenize, finding small data sets. So that's how it's going. Detailed discussion will be there, but based on the context, you need to apply it. So in your case, you need to test hallucination, test whether how efficient the base model is working, whether it can answer self-related questions. Let's take, who are you? When have you been fined? So what is your cutoff date? So these sort of things you need to prepare test cases. All right. So any other questions? Yeah, Teja, you're asking something.
Yes.
Yeah, welcome. Okay,
Your voice is breaking. Looks like you have some network issue.
that you are going to cover agentic AI.
So
AI.
yeah, team might yeah. So, I didn't get your questions. Your voice is breaking. I request you to post your question in chat.
Agentic AI.
Yeah, Agentic AI, as I told you that it's a part of this course. So if you look at the
Yeah.
content,
Yeah. I mean, the project also covering.
yes, we'll have projects on Agentic AI also. Here you have newsletter project on Agentic AI, blog content generator on Agentic AI, right? We have products on Agentic AI.
Yeah.
Any other questions? All right, that's it from my end. If you have any questions, let me know. And I will start sessions from tomorrow, the same time, 6 a.m. IST, the same link. And the first two sessions are going to be free. So you can attend session and you can take a decision whether you want to enroll to the course or not. Right? And we'll start tomorrow with Anaconda installation, Jupyter Notebook IDE basics, and then Python basics. We'll start with operators.
Dhamodhar.
Yeah, so request you to join with the same link tomorrow at the same time, 6 a.m. IST. If you have any friends who are interested in Generative AI, request you to refer them. Yeah. Thanks for joining the demo.
Thank you.
Teja, yeah, you were asking something. Hey, Teja.
Present, I have no questions.
All right. So, request you to attend tomorrow's session also.
Okay, sir.
Thanks.